About ready to go live here. Here we go. This will be good, actually. All right, I'm allowed put a backseating allowed tag. Okay. Okay, I think that's on. We'll see how it does. All right, looks like we're good. Yeah, so welcome back, everybody. First things first, you may notice I don't have the headset mic on today, and because that's actually part of the big news for today's stream is I got a new microphone. One that's hopefully a little better. It picks up a lot more, so you might hear some of the background sounds a little more. My upstairs neighbors decided to start making a bunch of noise and such, so we'll see how it does. Feel free to ask me to adjust the volume if it seems to be too loud, too much in the background, or too little. Keyboard's kind of loud too, but I'm just kind of learning this thing as I go. So we'll work off that. Next thing, we're going to continue using the NeoPixel strip to light up the Millennium Falcon. Last time we got a basic structure kind of defined, some basic code put together, and it allows us to do some pretty cool stuff actually. So now we need to go through and define a better command set so that we can control this thing from a computer and not just by reprogramming the Arduino. Like I said before, the end goal of this is that this lighting kit can be used on just about anything, and we don't have to write code to change the lights. We can just create profiles using some cool program that I make or something like that. So that's the plan, and today we're going to be defining some more commands for it. And yeah, I think that'll be good. If we get some time, I might try and write a script to try and control stuff through like a Python script on the computer. I think that would be really cool to demo everything that we're going for. So yeah, that's about all I got. Future project ideas are appreciated. I've been trying to think about where to take this in the future. I've also had some thoughts on whether or not, or really what this channel should look like in the future. Because initially it was just people watching me make stuff, and it still kind of is. And I want people to collaborate and offer their ideas and see them come to life. So how do we do that? And I've been thinking about that a lot, checking out some things that I thought would be interesting. Maybe not. This is kind of a weird concept right now, and a bit of an unusual one. So there's not really a plan in place for it or a strategy in place that someone else has come up with. So we need to think through that some more. And you might notice over the next few weeks some changes on the channel and just the format or other things as I try and figure that out, what works best. And hopefully I'll come up with something pretty cool. And yeah, so let's get started. I'm kind of stalling a little bit because I feel like the command set thing is not that much work, but maybe it is. Things usually take longer than I expect them to, so let's just get started and see where this goes. Sounds good? Okay, cool. Like I said before, you may hear some stuff in the background. This microphone is really sensitive, and I actually have it turned way down, so let me know if I need to adjust it more. And I'm sure there's got to be some program that can filter out background noise or something on the fly, so I'll have to look into that too. Oh well, let's get started. I'll flip on over here and just do a sanity check for last time. So right now, all the LEDs are off, as we can see, and we want to go through and check that our program from last time that allows us to set specific LEDs to a color still works. So I'm going to go ahead and do that here. I'm going to set LED 25 to red. And we're going to check that real quick. And there it is. All right, LED 25 looks red, which means that we are looking good. And then I'm going to actually do that same thing again and turn it off. All right, and it goes off. Okay. We also probably need to clean up our messages here in the console. If we're doing a command set, we need a better command and then response kind of format. But we'll get there too. So let's get started. Let's see, that looks good. You can see everything pretty easily. I noticed as well. Oh, you know what? This is not the right. Already messed this up. This is not the right sketch. This is the right sketch. That was one of my test sketches, but I didn't load it to the NeoPix or to the Arduino, so we're good. Okay. Here is a much better. Okay. Here's the right one. So we have our lighting kit set still, our lighting kit library. I think now I'm going to create our command parsing library, which is what we'll do is we'll move a bunch of stuff here that handles commands already to that library, and then we will we will call this lighting kit stuff from that library. So the command library effectively will call the lighting kit stuff and do that. And so what we're going to do is be separating this thing into layers, where the command library is kind of our controller per se, and then our serial interface and such is more like our view. That's going to be we're going to be sending data to and getting it back, and then the lighting kit library is really our database at that point. It's the thing that we set values into the store and then we retrieve them from and as necessary. Now obviously the NeoPixels are all output, so we're really just setting values. We don't have to retrieve anything. So what that gets it into is that model view controller kind of format, which makes it a lot easier to move things around later and change layers without affecting other layers. So that's the plan here. As always, if you have ideas or thoughts, if you see I made a coding mistake, or you think, oh wait, no, I have a better idea than what you're doing right now, please let me know, because I respect feedback and I respect the ideas that you all have, and I want to hear what you have, because I think it would contribute and allow me to make something better than I could just make by myself. All right, let's get started. First things first, probably got to create these files. So let me make some new files in that folder, and then we'll pull them in. And I'm going to do this off to the side over here. In the meantime, let me know how your Sunday's going. I'm willing to chat about anything while I work, so any funny stories or interesting experiences or anything that happened during the week, feel free to let me know. All right, we'll name this command parser. Okay. And open. Actually, that was not what I wanted. Let's go file, and I guess it is just open. Okay. There we go. All right. And so evidently the way Arduino works, this is odd because I have the two open here, but the new files only show up in one. Evidently, when you open up the .ino file, the Arduino type of file, it goes through and just opens up all the C files in the folder, in that same folder, which is interesting, makes sense, but kind of a weird way of doing it. I've also just realized that this is wrong. It needs to be, excuse me, It needs to be a C++ file. So let me fix that. I'm going to close this again, and we're going to fix that real quick. Yeah, snow tonight? Oh, man. I don't like rainy Sundays. And snow before the Monday. That's the worst. You gotta go to work in the snow. Okay, there we go. C++ file. All right. If not defined, command parser h. And this is just our usual header stuff, just to make sure we don't double define something. And then we end it. Cool. All right, next we need to go to the main and start figuring out what needs to move over. And I guess we could go ahead and just do our includes as well. So in here we want to include our lighting kit. Whoops. I just decided to throw an update there and stop me from being able to type. .h. Save that, and then in here, probably we want to include. Actually, I don't know that we need to include in that file, but we do want to include our command parser .h, and we're definitely going to want to include lighting kit .h. I suspect we don't actually need to do this, so I might just take this out right here. All right, that looks good, that looks good. And then over here, we're gonna include our command parser as well. So, even though I'm doing this in C++, I am actually writing things in a very C style. I'm not using objects, you know, other than the ones that I kind of have to for the Arduino libraries, like the serial object and the NeoPixel strip for that library. So yeah, the strip library. And the reason I do that is because I'm used to only working in C. A lot of the stuff I've worked on is very resource limited, and I just don't have space for all those objects, so I have to be very careful. And that tends to bleed out just how I do everything. So in C, there is a certain art to creating an object-oriented style without an object-oriented language. And as you know, we kind of know, like, an object is an instance of a class, but a class is really just a structure that also has functions. There are different types of classes, and you can control access and things like that, but at its heart, that's really what it is. Excuse me. So we're actually going to do that, a version of that, to kind of emulate an object-oriented style. We're going to create a structure that holds the command, and then we're going to create functions, and most of those functions, the first argument that you pass in is going to be that structure. And then we can create, basically, even though it's in C, and even though this isn't really necessary because our environment has plenty of RAM and stuff, it's just the way I'm used to doing it, it's an interesting way to see, oh, we can do a style of, it feels like object-oriented programming in that we're using some structure as the base of every argument that we pass into every function, but really it's not. It's still C. There's no objects. It's just a structure with some variables in it, but the way it's used very much feels like object-oriented programming. So, and I'm pretty sure I've looked around before, and there's been books written on that subject, how to write C in an object-oriented style, so that you can use it kind of that way, but it's not actually, it's not C++, obviously. It's not object-oriented. So if you've never looked into that, it's very interesting. Let's get started here, though. So lighting kit stuff needs to come into here, and then we need to go over to main, figure out what our basic commands are, and move those over. Let's see. Okay. So the first thing that it's doing here is just getting the command and then parsing it into a buffer. We'll need to move that, and that buffer is going to go exist in that structure in that command parser library that I was just talking about. And then our process command, that function's definitely got to move. And let's see, add to command buffer, reset command buffer. Yeah, both of those functions got to move. Okay. And we're going to change how they work anyway, so I'll move them over, but they're going to change. Last time we made a basic command to just prove everything works, but we definitely need better. So I know that I'm going to need those functions, process command, and then add to command buffer, and that should be the receive data. That makes sense. And then reset, yeah. So all of those will be needed, but they'll have to be a different style. Okay. I guess next thing I need to do is, oh shoot, I'm so sorry. Nobody pointed out. I wasn't even showing you the screen as I was doing this stuff. I'm so sorry. Hopefully that didn't go on too long. That's what I get for starting to. I've created different like scenes now that I can flip through as I'm doing things, and that's what I get for switching between them. I forget to go back. Okay. Let me just Google this again. Like I said, I do a lot of Python too, and so I just forget how to do stuff all the time because I can just look it up. All right, struct books. Can we not type def this? I'm looking at a bad example. Okay, any questions so far, by the way? I know this was a lot of info really fast, so I'm just trying to make sure that I don't. Yeah, okay, that's the right way to do that. Okay. Type def, struct. Yeah, if there's any questions, let me know. And then we want this to be, I guess we could just call it command. Okay, and then in that, we need a few different things. We need the raw command buffer. So command buffer. And then the command buffer length, we probably need to define that as a constant. Whoops, there's probably caps. Command buffer length. I think we decided that was 64 last time. So we'll go ahead and put that in there. And then so that's the raw buffer, and then I imagine we're going to want items to put things into. So we're going to want to put like command type, and then we're going to need an array of like parameters basically. So let's see here, and I know I don't have a whole lot of stack space, so I'm not sure how much of this I can go through and just do, but well, we'll see. So command parameters, and then max params. We're probably going to want that to be like, let's go with 4 for now. We can make it bigger later. At some point too, I'll probably move this thing from an Arduino to another board, which has more power and more memory. All right, max params, and then we also want the length of each individual parameter. If we're allowing 4 total, and we allow 64, let's say, I'm going to put 16, but we might have to increase that to 32. I don't know if 16 characters is enough. All right, so we're allowing up to 4 parameters, and then we're going to allow parameter length of 16. And then as far as our command type goes, I imagine that'll be at the same length. We can use param length there. Actually, let's make its own define so we can change it later if we need to. Type. And then let's make that, for now we can just set it equal to param length, but later. And then I would like these things to be aligned because it feels better. You can really hear the keyboard. Yeah, I was a little worried about that. The keyboard is really loud, so I apologize. I don't have a great option right now for getting rid of that. I'm trying to figure it out, but for the time being, I'm really sorry I can't mute the keyboard that well. Okay. Here we go. So now we got our structure. Now let me go through and, so the first item in all of these will probably be to, oh shoot, we probably need a pointer too. Let's see. It's gonna have to be a 16-bit at least. This is the index. It's not really a pointer. It's just an index that shows where in the command buffer the next character would go to, basically. Okay. So that's good. So now, first things first, in our reset command buffer, we need to go through and reset everything. And we can use memset for that. And then as well as a few other things. So command received. False. We probably need that Boolean in there as well. For if it's received a full command. Okay. Let's try that. All right, so first things first. Reset, we're gonna have to pass in a command pointer. Okay, we'll name it current command. And then we'll have to say command received equals false. Current command. Does Arduino let me, like, it doesn't let me pull things off to the side. That's really annoying, actually. All right, our index needs to go back to 0. All right, and then we need to go through and memset everything. So current command buffer, I believe, is the next item right there. Yep, and then the length is going to be that. And then we need to go through and memset each of the parameters. So for int, I don't know how big this thing's going to ever get, so I'll just do a 16-bit. count is less than, should be param length. Let's see. Oh, we got to do command type too. Forgot about that one. Yeah, let's do that one first. I know I'm all over the place. This usually happens when I'm designing the code as I write it, rather than like. So I've thought about some of the structure of this, but obviously there's still a lot that I haven't thought about. That's another reason the format of this channel is going to have to change a little bit. Is like with the Falcon, and even last time, I kind of knew already what I was going to do before I did it. And with the Falcon, it's just following instructions. It's already planned out. We're into a different territory here. Everything we do from here on out is not really planned beforehand. Which makes it more interesting because I get to solve problems on the fly. And you get to help me solve them, but it also means that we move a little slower, and it seems a little more chaotic because I don't know what I'm doing beforehand. We got to figure it out. All right, command type. We're gonna set that to 0, and then that's the length of that is just the same as the param length right now. Oh, but we set it as its own thing. I need to update that. Oops. There we go. Okay. Command type length. All right, so now we got to go through and do the parameters. Count is less than max params. We're going to go through and memset each of those arrays, each of those strings, character arrays, to the param length. All right, and then we know that we want 0 to be the thing there, and then what's it called again? Command parameters. So we're going to say current command, and then pointer to command parameters. Okay, that looks right. I should probably try and compile it here soon and just make sure everything works. Let's take this and put that in here now that we have it working. Okay. All right, so that function looks good. So now anytime we call that function, it's going to go through and not only reset some buffers, but all the pointers and the booleans, everything that we possibly need in that structure. And you can see here, like I was talking about with my object-oriented but in C kind of style thing, is that we're using C, but we're passing in a structure that contains all of the variables. So this function can only use that structure. So it's kind of almost as if this function is part of that structure, kind of like a class, which becomes, and then we have an object from it. But we're doing it in C, we're doing it without objects, we're just kind of pretending to. Okay. Process command, that one we're going to leave till last because there's quite a lot to it. So add to command buffer, that would be probably the next one we want to do. So we're going to want to do command, and we're going to do the same thing. The reason I'm going to do this is because I feel like it pretty well writes itself. All right, and then command buffer. All right, so we'll have to do the pointers. Receive data, and then what's the index? Is it just command index again? Command buffer index. Very important that we get that right. Yeah, just like it is down there. Okay, equals the received data. to have to do a pointer to that. And then we'll have to increment that just like we do down here. All right, we can probably take out the serial array. I'm gonna leave it in for now, but eventually we do need to remove it. Remove this. All right. And then I'm not even gonna use this process yet. I'm gonna comment this out so I can compile and just see if there's any major errors. I'm definitely not an expert in C programming, so this is just me. So like, that's part of why it'd be awesome to have people willing to help. But I'm just gonna stream everything I learn. So, all right, this Boolean. All right, there we go. Put that there. Well, I hope that works. Let me go to the main and take out anything that I think is going to cause it to crash. Probably don't need to include lighting kit now. Well, actually, yes I do, if I want to leave all this stuff the same. Maybe I don't. Let's just start commenting stuff out and see what works and what doesn't. Add to command buffer, which is here. And actually, I'm gonna change these to be like the, so whenever I have functions in libraries, I like to give them initials at the beginning of the function so I know kind of what library it's coming from. So I'm gonna do that here as well. I'm gonna have to go change how they're called in the main. Okay, so let me comment this one out. And actually, for this to work, we have to have an instance of the command buffer as well. So for the moment, I'm just going to comment this out. And we'll comment it back in a second. This is the secret to making good code, is just to comment everything out until it works. Okay. That looks good. All right, what goes wrong? UN16T does not name a type. Really? Have I not done that? Yeah, I've done that before. Did I type something wrong? Did you mean character 16T? All right, well, there's got to be more than just that error then. All right, looks like I got some stuff that's messing with me. Oh. That's definitely wrong, but I have never encountered this error before. UN16T does not name a type. Something is not declared right, and it's causing a cascade of errors. Let's go back to the beginning here. New file, command parser, let's see. 16T does not name a type. So it's calling that here. Did I take out the lighting kit thing here? I did. So why is that coming up there? Anyone have any thoughts? What the error could be? There's something obvious that I'm missing, like I bet you, like it's got to be like a bad bracket at the end of a header file or something, maybe. That should work. That looks good. This is a perplexing error. This is a good one. Declared void. I'm a little confused. Let's see, hold on. Let me bring the lighting kit back in here, because it seemed to work here. Alright, same set of errors. Let's see. It still threw an error there. That's so weird. Did I include it? I did. What happens if I throw it underneath here? Should throw the same errors, I imagine, because I haven't actually changed anything, but... Maybe this is a common mistake made. A great way to do this stuff is to Google it. What does it say? UN16T was not declared in this scope. I imagine this has to do with a format of a header file or something. I'm doing something that's definitely not not getting through right. You need to include standard int.h. Really? That must be included by default in the Arduino stuff, but why did it work in the lighting kit before? Does that fix it? Serial was not declared in the scope. Okay, that makes sense, I think. Yeah, that's got to get taken out. Wow, that did actually do the trick. Okay, so for whatever reason, the library just didn't have access to that value, but now it does. That's odd. I'm genuinely a little perplexed about that one. We'll see if it works, though. I guess it's fixed now. Okay. What's next? Memset was not declared in this. Okay, so that's happened before. I guess in the Arduino main file, like a lot of stuff is included by default, but later on it's not. That makes sense. I would think I would need to include the string.h file to have access to that. Reset command buffer was not declared in this scope. Yep, that makes sense. That tracks. Remember, just comment out your bugs. It solves them all. Okay, that works. And I've already used 11% of my 227 bytes for those structures that I just created. So I'm gonna have to be very careful about making them bigger because I'm gonna run out of. I'm not gonna have a lot of space. Okay. So that looks good. So setup. So what we need to do here now is actually create a structure. And then we can do serial stuff as well. I don't think... We don't need to do any of the serial stuff in the command parser. The one I commented out can stay commented out. We might have to for some debugging, but for right now, I think we'll be okay. Is greater than or equal to 0. Okay. We can get rid of these. And instead, we're going to do command, current command, and then here, we're going to do cp reset command buffer, and we're going to pass this in. Pass the pointer to that in. And that should get us started. And then we'll see our loop run, but for the, and actually we can just go ahead and actually add that now that we got the command created. The command structure instance. All right, and then I think here is where we want to do our repeat. Serial.write received data. Just to ensure that we're getting it. Okay. So every time it goes true, it should reset the command buffer, and we need to actually pass it in here as well. So all our main loop is going to be doing here now is just receiving data, and then asking the command library, the command buffer library, is it good? Do I have enough? Once it does, it's gonna the command library will respond true, will return true to this function, and then we can go through and say process. But for the moment, that's a good start. All right, does it compile? Nope. Cannot convert command to command pointer. Okay, that makes sense. How about we resolve to the address for that? I'll probably take that out actually and just go through and change everything again. But I just want to be safe though. Okay, that looks good. All right, let's upload it and verify it. All right, it's uploading. And this is not going to do anything on the NeoPixel, so I'm not going to show that. Got lots of question marks coming back. Oh, I know what's going on here. We don't want to send the data back unless we actually receive some. So that's going to be here. So read data from the serial port. Check if received. Data is received. All right. Excuse me, have a quick thing here. All right. And then down here, if we have received it, send back the character. And then process character. Okay. That should be a little better. Compile that, and let's upload it. Give it a second to upload. It blinks a bunch of green, yellow, and red lights when it uploads. It's kind of cool. Okay, now, test command. Hey, there it is. Okay, so we're getting it back. All right, looks good. The next thing we'll have to decide is how we want to do all the commands. I thought about that too. A lot of times in the past, if I'm passing a lot of data or a lot of different things, I've used a library called Jasmine, JSMN, which is great for embedded stuff. It basically uses JSON format to pass things back and forth, JavaScript object notation. And it's just a nice, small, very simple library without too much baggage that can process, JSON objects into tokens, and then you can pull them out and put them into whatever variables you need to. I think in this case, though, JSON is actually a bit too bloated. I really do need it to be very small, like the absolute minimum information necessary for a given command. So I'm probably going to take some thoughts from that. It's going to be a custom command set. And I'll take some styles from that, but it's not going to be exactly JSON because we need to cut out some of the baggage so that this can run fast. NeoPixels require fast interfaces, so we'll start with that. All right. So now we need to implement our process command. And this is probably one of the most important ones because we need to verify that it all still works and that our NeoPixel library still works. And it's going to be really disappointing if it doesn't. All right, and then we'll pass in our current command. Okay, let's go to our parser here. Let's comment this back in. The serial writes are going to have to come out because they're not in this library. All right, and then we're going to need to get the pointer. And change the name of this. And then finally we need to add this to our header file. All right, and then in here we need to go through and fix everything, all the references, because they're all wrong, literally every single one of them. Our buffer here, let's see, what's our temp buffer size going to be? Probably 64 as well, just in case. This is capitalized. You know what? Let's do the parameter length plus the command type length. That way we know it'll be long enough for either, because the temp buffer is just going to be exactly that, a temporary buffer for moving things around. Actually, now that I have the items, and it may not be necessary anymore. Interesting. Okay. Yeah, I think I need temp index. I actually don't think I need this anymore. All right. So let's change this. We're gonna have to go through and rewrite a lot of this, but that's okay. Excuse me. Whew. All right. Let me just think through how to do this right. All right, so imagine what we'll do for the actual command is we're going to do something like this. So, whoops, sample command, and we're going to do bracket, open curly brace, command, semicolon, param1, param2, param3, param4. We know we said right now that 4 is the max limit on our number of parameters. So do that, and then close curly brace, and then obviously new line. So I think that's what we're going to do for our command set. And we're not going to require all 4 of these parameters. So the first things first is I got to pull out the command. So first thing I have to do is check that there is, for a valid command, there is a curly brace. So I think I don't need this temp buffer. I think I'm going to rewrite all of this basically. So let's just start working through it. Index and all right, raw command index. This will point to the incoming command buffer so we can move through it. So we'll start that at 0. All right, so the first thing we're going to do, so let's set up variable. And actually, I'm going to just change the name of this because it doesn't do the thing now that I need it to do any longer, or that it's going to do something different than what I currently am saying it does. All right, so this is going to parse the current command into structured variables. So what this function is going to do is take this command buffer, which is what we fill up when we receive them, and then it's going to parse them into the command type and the command parameters and put the appropriate values in there as needed. A command type will help us because that'll determine what parameters need to be what, so we already know types and things. I'm going to try my best to handle error cases and stuff here, but we might have to get kind of creative. And then, yeah, that's just for incoming stuff, and then that's just if the command has been received. So that'll be set to true. Well, that's actually already set to true at this point. But this function right here will return true if it's a good command or false otherwise, and that's how we're going to do everything. So first we got to check over the opening brace. If current command, let's see, if current command, and let's go here, current command, where are we looking at? Command buffer, yep. I really wish Arduino had autocomplete stuff. That would make this way easier, but it doesn't. Next time we're doing this in a different environment. Arduino's great because it's easy and simple, but either I need to find some good plugins for it or I need to find something better because it's got so many, like there's so many coding features that it feels like it's missing. All right, so we know this should be the first item. It's not equal an opening curly brace, and we're going to return false. So basically, that's saying if the first item is not an opening curly brace, this is a bad command. And then, okay, yeah, that'll work. And then here, I think we do need to do something for, okay, we need to parse. And then we'll just abuse Arduino a little bit here. If not this, so if it returns false, serial.write, and then this I can actually use a string, so okay, serial.write, invalid command. And then I think at that point we probably want to stop there. We still want to reset the command buffer. Otherwise, else, it is a good command. Serial.write. Command received. Is that how you spell received? I can't tell if it's... No. I can't type properly when it's uppercase. process command here. All right, so that's where we're going to process the command. And then here was the reset command. Uh-oh. Escape, escape. I hope everyone appreciates the awful programming practice that is commenting after you've written the code. You should definitely comment while you're going through it, but you know. All right, so while command buffer raw command index does not equal semicolon, and this is actually going to go through and this does some of the same stuff that we're already doing. Then we want this to be our command type, so we want current command type. All right, and the temp index, yep, to equal our command buffer, which actually we need to fix this everywhere. And then once again check, is the name command? Yeah, it is name command buffer. Command buffer temp index, not temp index, raw command index. Okay. And then we need to increase both of these. All right, so what this is going to do is go through and copy all of the text after the curly brace into that command type until it finds a semicolon. I'm starting to see why a JSON library could have been a little bit easier here. Okay. Next thing's next. We don't need to convert stuff to like integers and things like that. What we need to do right here, where is that used? I was trying to remember what I did last time. What we need to do now is go through and get all the parameters out. Sorry. Move to, and this should be get command type. Okay, so then moving to the parameters, we need to increase this and index. Again, that'll look past the what is it called? Semicolon. Into the next next thing. All right, so raw command index. And then we probably need a loop here to do this. So for int 16p count 0, count is less than, let's go with max params because that's what we're doing here, so that can change later. Plus, okay. And then for this, we need to go through and find a comma for each one. Right, so now we're looking at the parameters. So the next step is we got to get the first parameter in until we find the comma. So while let's see. Let's see, right, what do we want? This one right here. While the raw command index does not equal a comma, or we need to check for 2 here actually. So I'm going to actually put another set of parentheses around this. We need to look for 2 different characters. So while that does not equal a comma, and it does not equal a closing curly brace, because after the last parameter, there's no ending comma. Meaning that it would never find it and it would just keep running for forever. Yeah, this is going to be really fun to debug, I can tell. All right, so while the current thing looked at is not a comma or a curly brace, we do the next thing. And actually, let me go ahead and add a statement here. Check for end of command. And this is process parameter. Process, whoops. Huh, process is a keyword. Yes, all parameters. Then we need to do an if, and we need to check this specifically. If it's a curly brace, we are at the end of whatever we are doing right now. So if it's curly brace, we need a break. Now, notice that we're going to break anyway once we have 4 parameters. But we also want to break early if there is if there's less than 4 parameters, because we don't want to keep on trying to process, junk data. And then here, we need to increase our raw command index to look past the comma. So break gets us out of a loop. So if we hit this, if we decide that it's a curly brace, we're going to break, and we're actually going to exit this for loop, so we won't even hit this. And then, so here we got to do the same thing we basically did right here, but for each parameter. So I'm just going to copy that in and change a few things. And then we're going to want to do command parameters, current command parameters, temp index is 0 right here. And then, so just so we keep everything clear, copy the character. Even if it's something really dumb, I love to put one-line comments on everything, because it kind of reads through. When you're trying to figure stuff out later, you can almost read it like a book, and then, of what exactly it's doing. Makes a temp index to both need to go up. Okay, current command buffer, raw command, temp index, and then here this is a 2-dimensional array. We need to do count for our parameter, and then so we got our parameter, and then temp index. Okay, temp index pointing to a specific item. So I realize very well that, especially with C++, there's a lot better string concatenation methods that we can use, and processing methods, but writing this stuff out helps you to very visually see what's going on. All right, that looks good. And then down here, check for the end curly brace. We already kind of did. If it's not there, we're going to have an error. I guess we also want to, and then if we want to be absolutely safe, we should, we should just do this again. Right here, and say check for a new line, because that should be at the absolute end of this thing anyway. All right, and then we'll double check here that everything works right. Check for closing brace. So if current command does not equal closing brace, turn false. And then we know every command has to end with the new line character. Check for new line. And so we'll do this again. do a new line character. Okay. So that should copy everything in that we could possibly need. And then we'll have to go through and actually process anything that comes up. So just so I can have some reference or previous code, I'm going to go ahead and comment all this out. And just return true here. But I want to look at this later because we're gonna have to add another function called process command. So this is parse command. So once you've parsed it and figured out all the items, then you have to actually use those to perform action, and that's what we're gonna do. So should be good. Hopefully everybody. I know it's a slow Sunday, and this is probably not the most exciting subject, but I promise we'll get back to the lights here soon and making them light up. We're just trying to get all the software in place to control these things. Okay. If anyone has any questions or anything, please let me know. Or any suggestions. Suggestions are welcome as well. All right, I think that looks good. I think now I can go to my main. I should be able to compile this. I wonder how many errors there will be. Don't forget your semicolons. Just that. Okay. I guess I gotta try it. And see if it returns valid or invalid command based on certain things. So let's try it out. Ram 2. Oh, I need a comma between these, not a semicolon. Oof. And 3, and then param 4. All right, so all of that should work. Will it? I don't know. Invalid something. I probably crashed it or erased. All right, well, I didn't think it would work on the first try. Let's reset that and try again. All right, maybe it was a memory issue or something. Let's go to our example here. So the reason I'm not including the new line at the end is because the serial terminal does that automatically. So let's connect, and let's just go down to like 1 parameter. And send that. All right, didn't reach it. We're stuck in a loop or something. That's disappointing. Okay. So how to debug this? Always the tricky part. I don't want to move this function here into the main, but I probably have to debug it because I need to be able to use the serial thing. So, all right, let's try that. All right. Arduino is fun to work with when it comes to debugging. Let's make sure it all compiles again. No issues? All right. So now, because it's here in the main, I can use these serial.write things, and I can try and just see how far it's getting. So let's just verify that we get the same behavior. Start the serial terminal. I guess it doesn't matter if it's capitalized or not. Command param. I need the semicolon. All right, send that. All right, it got it. It didn't respond to anything, which means it doesn't think it's at the end of a command or something. So that should send error. So yeah, so something's definitely wrong here. All right, let's go to here. And then what we're going to do is just see how far we're getting. So we'll just go ahead and put in a bunch of serial print statements. And then what this will do is we'll change the number on each one. And this will let us know. So like this one will be 2. Go down here after this for loop and do 3. So this will let us know just how far we're getting before something goes wrong, before something stops working properly. 4, 5. Okay. There's probably just some basic logical error going on, but it's really hard to find if you don't have something like this to just guide you there. All right, didn't even get to the first one. Interesting. Okay. We're not even using anywhere close to all the memory yet, so that shouldn't be the problem. Weird. Let me see here. I guess right here we can put a 0. Oh, you know what? I probably didn't even compile that and upload it, which is why it didn't do anything. It's always good to put your test code actually on the device that you're testing. Okay. And then param. 0, 1. That makes sense. Something went wrong there because I didn't include the semicolon. We should probably put a check in here, because if you don't include this, and this thing reaches that point, semicolon. Maybe there is just a command that doesn't have any parameters, so I guess we didn't take that into account. I guess we need to include that. It's an option. Or equals that. Oh, shoot. No, wait, this should work. No, it shouldn't work. We need all of these to be true at the same time. I think an or is the wrong statement here. I think it has to be an and. Because it can't equal this, and it can't equal that. I think that's where our major problem was. Is that this statement was still true all the time, so we were just running to the end. Man, Boolean logic's hard. Okay, upload that. And then turn on the serial terminal here. Oh, it's hidden somewhere. There it is. I'm going to reopen it. For whatever reason, whenever I turn the serial terminal on, it resets the Arduino. I don't know if that's a thing Arduino is supposed to do, or if it's just my specific Arduino being weird, because it's an FPGA, not an Arduino. But okay, let's try that. All right, still 0 to 1. So it got to this one, solid as curly base, got to 1, and then it did not reach 2. Okay, so what's next then? Something in here is going wrong. So let's just do serial.write, and then let's just do the received command, or the whatever the current item is. That'll probably tell us something, right? Error. Semicolons. Is there a compile button? Yes, Control R. There we go. Is there an upload? Control U. No underlining in this. Okay. Oh, we already uploaded, but I'm gonna upload again just to be sure. You never know. Sometimes some of those bits are a little weird. All right. Command param 0, 1, and then it solved that and stopped. Didn't do anything else. It never looped again. It just broke. So I've got to be messing with the memory or something here. Is the way I'm referencing these structures correct? Is it supposed to be a dot operator versus this pointer operator? Well, no, because this worked. Right? So that should be correct. Command type temp index equals raw command index. Why isn't it looping again? I'm not getting any warnings here about this. I don't know if anyone has any thoughts. All right, let's try this. I'm gonna have to go through and remove so many debug statements when this is done. I feel like this shouldn't give me any new information though. It's got to fail right here because I don't. These are just increments. Like there's nothing weird going on there. All right. Or upload. Then open the terminal. Close that and reopen it. Well, okay, hold on. Command param. All right, we're gonna have to fix something. We're gonna have to do something else here. Otherwise, I'm not gonna be able to read this. We need a new line after each character, because otherwise I'm not gonna be able to tell what's going on. Oops. All right, let's get this uploaded again, and then we'll give this another shot. On the monitor. All right, COMM, and then it stops. Something, so memory-wise, something has gone wrong. Here one, here. Yeah, memory-wise, something is messing up because it's only writing a few characters and then giving up. So what could it be? Command type, command buffer. Do we use the wrong thing in here? Command type is command type length, which is so is param length, which is 16. Command buffer is command buffer length. So we're not referencing outside of that. Huh. We probably want to go ahead and just print this after we receive it, just to see that it's receiving correctly. Yeah, let's do that. In the main here, parse command. Oh wait, no, that's what we're doing. We're trying to parse it. So we must be referencing something wrong then. Or something we're receiving. This one, add to command buffer. This is the one I'm talking about. I feel like something here is going wrong. It's not getting added correctly, and things are getting weird. Let's just take it out. Move it to the main, debug it, send it back. So if this is true, I'm just going to print this out. Hey, that's kind of cool. Serial.write. And then we're just going to print this exactly. Just to see that we're receiving it. So this should, basically we should see a command that gets received get printed twice. Assuming it's working. All right. Exit out of this, reopen. Command param. And it did. So I think we're definitely referencing that structure right. So why is it running out of memory? Or why is it having memory issues? This is really perplexing. Well, it's all the fun stuff too, though. You don't want boring bugs, you want exciting bugs, things that make you want to pull your hair out. I'm using 11% of the memory space. It's probably the most I've ever used on an Arduino before. Pretty intense program. Okay. H0, H1, stops. Okay. Why? That's such a weird place to stop and just break down. See, oh wow, and it didn't even get hardly through it at all that time. No, there's gotta be something that I'm missing here. Something very obvious. I don't know if anybody knows anything about Arduinos. It's gonna be really disappointing if I can't even get this part done today because I got this bug. I wish I could debug. But water. All right, let's just breathe and think for a second. There's something going on here really weird, and we don't know what it is. What if I don't copy it? What if I just copy this line out? It's got to be this line that's causing the problem, right? Okay. Nope. Something kills this before it even gets that far. There's got to be a memory issue that's just overrunning something somewhere, and I don't know what it is. Oh, man. What could it be? Because it's just flat out not working. It's too much serial print stuff and it just stops. I bet if I took out the 0, 1, it would go farther. Probably could go ahead since I know it's making it that far. But what buffer is it overrunning? This is gonna be, man. Well, I'm glad you all are watching as I try and figure out this crazy little error. Nope, still didn't go that far. What is going on? That's making it just freeze up. There's not a watchdog on this thing that I'm aware of. That would make it sense anyway, since it keeps hitting the same point every time. Does anyone know? This is the most perplexing thing. Let's see, which one does it rely on? Command index? So what if we don't increase the temp index? Okay. Nope, still frozen in the same place. It's got to be something simple. What happens if I send something else? Shouldn't do anything, right? Yeah, it just started breaking down. I don't think there's any interrupts firing that would be distracting it from doing this stuff. Oh, man. Well, can't win them all. But this should be a simple problem to solve. Let's see. Yeah, it still does the same thing. Oh, I think I did just notice one error. I need to increment the raw command index here. Because we're using it to check for this brace, and then we need to move past that brace for the commands. Alright, well, we did find an error, but not the one that I wanted to. Not the one that's causing this headache. Let's see. All right, and then that even went less the ways through it. Maybe there's something getting messed up with the command buffer before it gets passed in. Maybe it's up here that something's getting messed up. Hold on. Right. Command buffer. Alright, so we should see it show up 3 times. Oh, that worked. Okay, so it looks good coming in. It's when we start messing with these variables that it just seems to go wrong. I'm just, at this point, I'm checking everything I can possibly think of. Oh, wait. Oh, no, wait, that doesn't work. Okay. Let's do this, too. Put that right there. Try and print it every time. This will probably cause it to fail, like, immediately. All right. And parameter. Oh, I got farther that time. It prints it fully every time, but it still just at some point just stops working. Oh, man. So the source buffer is not getting screwed up at all. It's working fine. It's the, but it's, I don't know that it's the receiving buffer either. It's got to be a memory issue of some sort. Bad pointer to somewhere. Here, let's do, right. Now let's print this buffer, the receiving one. Maybe something there's getting messed up. It's going to weird places or something. We could see if I need a new line after each one. Okay, it's uploading. Well, this is fun so far. I'm having a really good time. Oh, we're not increasing the temp index, so that's already not working right, but nothing, C0. Let me fix that. Hold on. Increase that again. Okay. Weird. So we can see how it's processing it correctly. See. So you can see how the receiving buffer is receiving the next letter every time it loops around, which is what we want it to do. But we don't. But why is it just stopping? Like, because it's not getting to any of the other serial write statements. Like, something's just literally freezing up. Is it all my serial statements that are not working? I literally just comment all of this out. We know this is getting it correct. Verify. Wonder if it'll go farther if I do this. Yeah, I got farther. Oh, no, it didn't. It didn't even get there at all. That's really disappointing. I'm wondering if this has something to do with the way our structure's set up and with the way we're just setting it all on the stack. I wonder if we really do have to like allocate all of that. It wouldn't hurt. I just like hate that's a thing, but I think that's probably a good way to start. So we're gonna need CP init, buffer init, and actually we want this to return a pointer to a buffer. So we want command pointer. And then we need void cp buffer dinit, deinitialize, and that way we'll actually have to get the pointer. I don't know that we'll ever necessarily call this function, but I want to have it just in case. All right, let's go. It's entirely possible too that this is overwriting something somehow. This all these mem sets. There's length. I didn't think about that. Type length. Rams. Oh, I think I found it. Right here. Current command, command parameters, and then actually we're trying to memset a bunch of buffers within this. We're probably erasing stuff or we're overwriting into a weird area, weird behavior by doing it this way. We're probably overwriting pointers and things. So then this should be count. Hold on, this may not be necessary yet. Let's see if that changes anything. I really hope so, because that would be epic if that was the error. And it could be. Dang it. That wasn't it. That hasn't fixed any. That should fix something, I would feel like, because it's a like really bad memory thing. So that's really disappointing. All right, well, I guess we're doing this init function then. All right, so what we need to do here is create it. Command, current, command, create structure, and then we need to go through and allocate everything. So the primitive types will allocate, that'll be fine to be on the stack. Things like this index and this Boolean will be just fine. What we need to go through and do is allocate all of this. So, yeah. So let's start with the command buffer. Alloc. Oh, it's malloc, this one. Yep. Alloc. Current command. Command buffer. And then is malloc just the pointer and then the size? I believe it is, but I'll check it out real quick. Oh no, it's just you malloc the size and cast it to the item that you need. Whoops. And we know it's a character buffer, so equals character pointer malloc, and then it needs to be the length, the command buffer length, basically. So that right there times size of, good practice to do this even though we know what the size is, character. All right, current command. I hope this works. This is gonna be hard to debug too. Command type equals same thing. Except we need the command type length. All right, now this next one, we have to go through and allocate the size of the, so the pointers sizes. So command parameters equals character pointer to pointer malloc max params times size of character pointer. Okay. I wonder if things weren't allocated correctly. I'm just trying to think about how those memory issues could possibly happen in the physical memory. Maybe this does make sense. All right, and so then we need to go through and allocate all of the actual parameters. So count 0, current command count. All right, here we can change this to a equals malloc, and this needs to be a character pointer. And then we we want to do param length times size of character. Okay, and then after all of that, we want to return our current command. Okay, I think that'll work. And that's going to create a pointer of it, which we will then use in everything. So let's take this function. Let's go through and make sure it's in the header correctly. Yeah, okay, looks like it. All right, copy that. And go back to our main, go find our global structure here. Current command equals this. And then we can actually go through and remove this ampersand character because we no longer need to reference the address on everything because it's already a pointer. All right, and those functions are there. So how badly does this fail? Has non-pointer type command. Oh, okay, it's not a, right. And then we could probably just pass this back like so. Okay. Malloc was not declared in this scope, but it came up as a keyword. That's really interesting. All right, what library is this in? Instead, I thought I did. Oh no, I did include the standard library here. All right, fine. Include. Fine. There's probably a lot of bad practice going on right here. Okay, we're getting closer. All right, incompatible assignments. Incompatible types and assignment of character pointer to character 64. Command buffer. Oh, I need to change the definition if I'm going to do this. Yep. So this is a command pointer. Sorry, character pointer. This is a character pointer. And then this is a character pointer to a pointer. All right, verify that. And that looks good. Okay. Let's see if we get anything at all from it. It may just fail spectacularly, even worse than last time. Because now I have something else to debug. Yep, it did. Oh no. Well, what do we do? Because we know that this is, it's really important that we get this working. I'll probably, because we're running low on time here, and I don't want to spend 2 hours, debugging the same thing. So what I might do is try and figure this out outside of the stream, and so that we don't have to keep working on this. At least figure out what the bug is, and the next time work on it, work past that. I'm gonna spend a few more minutes on this, and seriously, if anyone has any ideas or thoughts on what might be causing this, please let me know. but yeah. Okay, so this didn't work at all. Is it even writing anything? No, it's almost like it's receiving nothing. Here. Let's do at least a setup complete or something. Just to see if the serial monitor is working at all. It should come up here. Yeah, nothing. My guess is it's not even getting through this function right here. So, yeah. We might actually have to do the C++ way and use new or whatever, just to make sure that this should work though, but All right, well, I apologize. I know this is probably not the most exciting thing ever, but I don't want to bore everyone with continuing to do this over and over again and try and figure different things out. I thought I could figure it out on stream, but I guess not. So let me see what I can come up with for this error, and then I plan on streaming again Tuesday night. So hopefully I'll come up with the fix by then. I'm just trying to think now. See, now I can't focus on anything else. I got to figure out what it is, what's causing this error, this memory issue, and why I can't just why I can't receive these parameters appropriately. So, all right. Apologies we didn't complete today's goal. Unfortunately, just me doing this was not enough. So I will look into this some more, and we'll figure it out for later. Thank you all for your time and attention, despite everything that went wrong. And we'll figure it out. We'll see. I'll see y'all Tuesday, and we'll move forward from there, and we'll finish this command set and then start getting some computer control working. And hopefully by then, I'll have my SD card little breakout things, and I'll be able to start adding a way to store and receive like profiles as well. So have a good Sunday, everybody, and I will talk to y'all later.